Hello everybody. Today we are going over how to set up our part in Inventor to get ready for camming. You do this step once your part has been fully designed. So we will start by selecting our cam ribbon up here. We're going to click into setup, and there's three tabs that populate once we select setup. The first one is setup, stock, and program. You're gonna have to go through them one by one in that order. So the first step is we're gonna select the machine. So we're gonna do using the lathe. It's gonna be turning. So sometimes you'll refer people. You will hear people refer to the lathe as turning. So if you ever hear turning, that's the lathe. So we're going to select generic lathe, hit OK. Our next step is going to make sure that our operation type is turning or mill turn. The other options are milling or cutting. I have no idea why we get those options, but you want to make sure that this is the operation type selected. Sometimes lathes can have multiple spindles. In our case, our Tormach only has one spindle, so we want to make sure we have our primary spindle selected. Our After that, we're going to want to make sure that our axis corresponds to our part. So as you can see here, Inventor's just made some generic bar stock, and they put our part inside of it. Our diameter is correct, but as you can see here, our Z needs to be corrected. This isn't producible on the lathe currently. So what we're gonna have to do is make sure that the Z axis is selected. So any point we click on this part, our Z axis will be perpendicular to it. So I can click on any of these points. So I'm gonna click on this right here. Now, as you can see, now my part's more in line with the bar stock. So this is now producible on the lathe. So that's all it takes. I'm always a fan of clicking on the stem and then clicking on the point that I want that axis to be perpendicular to, but this works well. So we're only concerned about our Z and our X. We have no Y axis on the lathe, so pay no attention to the Y. So if you wanted to correct, so if you now this is the front of the part. If we were looking at it in front of in the lathe, we would be looking at it like this. So this is now the front, this side, because our Z's right here. This little ball right here is our origin point for our axis. So let's say if I wanted to flip it, I can just hit flip Z axis. So now at the machine, I would be looking at it this way. So that's very handy if you want to change what is the front of your part. It can vary part to part. Ideally, you want to machine as many features as you can. Sometimes it's not always possible. You will need two setups. So you always want to make sure that your origin is set to stock front as well. So that's just more for G code. So any number behind this point right here will be a negative number. It just makes it easier to read as a program. So we'll ask people to make their stock front their origin point, and whatever front they decide to be the front of the part. So you can just model, select model. That's pretty much it. And chalk, that's referring to, this is more for the simulation. This is so where Inventor can know where the back of your part ends, and where is that in relation to the spindle. Um, if your tool ends up hitting back here, then Inventor will give you an alarm, an error message. Typically, you don't have to mess with this. It's more for the simulation. So that's it. Well, we are not gonna hit OK yet, because once we hit OK, it's gonna take all the information for all three tabs. So we're gonna just go back up here and go to our next tab. So our stock tab is for defining our material. So this is typically what you're gonna input for the physical material that you have. This more makes more sense once you've been allotted physical material. So this is just imaginary until you have something actual to work with. Ideally, there's a few different options here. It's from solid. There's from, let me see. I think the most common for the lathe, you're typically gonna choose fixed size cylinder, and that will allow you to change things absolutely. So like whatever this size is, it will be that size. I think the other one is relative. So it's just it it makes a box around what you would need as a bare minimum for your part, and you can add to it. It's just the easiest way to see what is the smallest size stock you can order. Um, Typically, the rule of thumb is you always want to buy material that is about an eighth bigger than what your final size is. But you can see here that information. But ideally, we're going to stick to fixed size cylinder. So it just makes it easier. Like I said, once you have your material in front of you, you're going to measure it with a caliper, maybe a micrometer. Once it, let's say if you're holding the part on the second op, and now you gotta work with more precise dimensions. But let me see. Um, so maybe length. There's some things we can play with here. Maybe if you're holding this with a inch and a half long, uh, let's say you want to give yourself that much material, or that was the size that you had, you can tell it where you can manipulate where your part is in the stock. I select offset from front. If so, now the part is more towards the front. This is ideal. Sometimes you wanna offset a little bit just to make sure that, like, let's say for an example, it makes sure that this radius will be produced. It's let me see. You can always have it in the center. I really don't like this method. It's just a lot of waste right here. Because all of this front will have to be machined. It just adds more machining time, and so I feel like it's a bit of waste of material. Offset from back. Let's see, 0. So now you see the back is absolutely set at flush with the back. Ideally, I like doing offset from front. Uh, uh, it depends. Offsetting isn't always required. It's more for if you got a piece of material that was cut really roughly, you might want to offset it maybe 0.1 just to make sure that you have a nice clean finish here. Get rid of any of that rough surface from like a saw cut or something like that. Oh, Here's another thing to take a look at here. Let's say I did this on purpose. 'Cause let's say if you were given a piece of material and it was zero point 0.5, I can visually see that my part isn't producible with that size material. The yellow again is the stock, so you can see whatever's sticking out. That is material that just doesn't exist for to produce this part. So you can sometimes play with this as you start what like this. I've seen sometimes that people have to go back to either ask for a bigger piece of material or they will have to change their 3D model to adjust for this. So it's just a good way to see if your part, well, if you have enough material for your part. So I put it at 1 inch. Uh, and let's go to the next tab. So the last tab is for naming your program. This top one, program name slash number. Ideally, you want to make a number. Uh, you absolutely want to make it a number. So you use the number to call up the program in the machine. So you can name it, I believe, anywhere from 1 to 6 digits. So you can, you know, 2, 3, 4, 5, 6. That's 6 digits. Uh, and then for the program comment, that's for you. So you can identify your program for what it's for. Ideally, you want to put maybe a description of your part, maybe first stop, second op, or your name. So I would put something like spinning top, first stop, operation. Uh, then I put Robert. It just makes it easier to find your part and find out what you're doing when you're at the controls. So I hit OK. So as you start going along, you can have multiple setups. It just makes it easier to navigate and stay organized. That was going to be the last thing I was going to say. You always want to make sure to hit OK. Um, Let me see. If you don't, if you hit cancel, or let's say for whatever reason you click away, uh, let me see. It won't save your work. So just keep that in mind. I've seen people do that quite a lot. Well, they'll go through all the tabs, click away to do something else, or they hit cancel and none of the work gets saved. So that's pretty much it. The next video we will be doing cam. Um, the lathe doesn't have as much as the mill, so hope to see you there. So the PowerPoint, in case you have any questions, that will be more in depth, explaining things about each tab. But that's it for now.